All right, so we're going to estimate limit values from graphs and tables. So since these notes I haven't really reformatted to fit my specifications, there's no blank up here that says ISN page like it is on every single other one in my notes. I'll eventually get there, but even though it's a date, we're just going to put we'll put the ISN pages up here for right now. So it's going to go on page 21 when we're done. That way you can put it up there and you'll remember. I know it says date. It's not the 21st, so if it helps you to go. And these are going in your notebook, so you don't even have to put your name on it. Oh. But you can. It's fine. It doesn't matter, but, I mean, I know you're used to that. But. Okay, so we're going to estimate limit values. Now, a limit. Do y'all remember the video that we watched with the ninja and the pizza stealing ninjas where he was heading to the refrigerator? Do I need to go get that video? It's not about what we actually get to. Whether we get there or not doesn't matter. Sometimes you'll be able to get there, sometimes you won't. All right, so we're going to consider this function here, this x cubed minus 8 over x minus 2. And we want to know what happens at x equals 2. So, well, what happens if I substitute in 2? It's 0, at least in the denominator. It ends up 0 over 0, but 0 in the denominator makes it undefined anyway, right? So the function isn't even defined at 2, so substituting it in doesn't do any good. So f of 2 is undefined, so we can test the limits a few ways. We can look at them graphically, we can look at them algebraically, or with a table. So we're going to look at this with a table, so I'm just going to show you this graph on, oh great, it's behind, let's see. There we go. So I've graphed that function. What does it look like? A parabola, right? And it pretty much is, because if I factor that numerator and then I cancel out the denominator, if I can cancel out a factor, what does that tell me about a function? It has a what? A hole. So there's going to be a hole in here somewhere, most likely at x equals 2. That's why it's undefined. It just doesn't kind of look like that right here. So if I go ahead and use the table, so I'm going to turn the table on. So there's where the numbers are. We'll zoom in just a second. But these are the numbers in the table. Notice that we've got 10 point, and I'll write them where you can read them in just a second. But they get here, and then 2 is undefined, right? So we'll just transfer these numbers onto our table. I think it'll be easier for you to read up here. Great. So this 1.75, we'll just do, it's like a 10.563. 1.9 is at 11.41. 1.99 is at 11.940. 1.999 is at 11.994. This is undefined, right? So it looks like it's getting pretty close to what? 12. Okay, so let's see what's happened on the other side of it. So this is 12.006, 12.06, 12.61, and 15.25. So don't worry, you're not always going to have to write a bunch of stuff out like that. There's going to be a lot of writing in here, but just this one time. The rest of the times, if you're doing that, you'll either be given a table or you'll be looking at one digitally somehow. So it says, it should be obvious as x gets closer to 2, the value of f of x becomes closer and closer to 12. We will say that the limit of f of x as x approaches 2 is 12. Okay, so those are the words that would come out of your mouth for this right here. The limit of f of x as x approaches 2 equals 12. And read this right here. Correct notation is extremely important. Okay? And not having linkage errors. If you're going to have an equal sign, it's got to actually be equal to the next thing, and you're going to have to rewrite a lot of stuff. All right? Just the way that it is. All right, so let's look at this. So this was just the limit, and we looked at it coming from both sides, right? But remember doing one-sided limits? We could just go from the left or go from the right. So this says the limit of f of x, the limit of f of x as x approaches some value of c from the left side is written as this. So I have the limit, okay, the limit of f of x as x approaches c, and it approaches it from the left. So there's a little like negative sign in the exponent, and that is some limit there. So if I want to say from the left, it's c, and then there's a negative up there. It looks like an exponent, but it really isn't. So then the limit of f of x as x approaches some value c from the right side, limit of f of x as x approaches c from the right, so there's a little plus sign up there. So in this particular case, as we approach from the left, we approach 12. As we approach from the right, we approach 12. And so since we're approaching the same thing from both sides, that means that the limit itself exists. So it says in order for a limit to exist at x equals c, going from the left must equal going from the right, then you can say just the limit itself exists. Okay? Depending on what we're using this for, maybe we just care about the left or the right, but and there'll be times where you'll have to say this limit is equal to this limit, therefore this limit exists. We're going to have to kind of explain ourselves on some of that. Right now we're just looking at stuff. Any questions about anything? Okay. So let's look at this graph. That is this graph. We looked at it a little closer, right? So since the limit of f of x, the limit of f of x as x approaches 2 from the left is 12, and from the right is 12. That's what we just did up there, right? Then we can conclude that the limit is, I didn't mean to mark it out. Then we can conclude this. So we looked at it from both sides. I'm coming in here. I'm approaching it. I never get there. The ninjas stole my pizza, right? And I'm approaching it from this side. It's about what we're approaching, not necessarily. It's possible that, and we'll see a graph in just a minute. So if you have this, the equation would look a little bit different. But it's possible you could have this, and here, this is at 2. I could have a point right here. So at 2, the function value is actually 20, but the limit as x approaches 2 is still going to be 12. Does that make sense? Okay. All right. And, so it's important to note that, well, in this case, because let me erase that now. I missed that last sentence there. It's important to note that the limit exists even though f of 2 does not exist. And it would still exist even if it existed and it was at a different point. So let's look at this example here. We want the limit of the function, and this is our function, as x approaches 1 from the left. So as x approaches 1 from the left, what's the limit? 1. It's our y value. The limit as x approaches 1 from the right is 2. So does the limit as x approaches 1 exist? No, because these are not the same. Okay? So this does not exist. D and E. If it said explain your reasoning, then you could write this and then the equal sign with the line through it and then this, like they don't equal, and that's why. Okay? What is f of 1? 2. So f of 1 does exist, but the limit does, and it actually even matches this limit, but so it says the limit of f of x does not exist because, and this is what we need to write that, we have to say the limit of f of x as x approaches 1 from the left-hand side does not equal the limit of f of x as x approaches 1 from the right side. So notation's super important. If you don't write the notation right, you're not saying what you think you're trying to say, and you definitely don't want to have to write it in words. You'll be writing paragraphs of stuff. We'll have to write some words too, but. Okay. Any questions at all? We got this? I think y'all pretty much got it pretty quickly the first time. I think you felt pretty good about it. So hopefully there was a few things that we got a little bit mixed up. So we're going to work with a partner. You can work with your, so you each have kind of partner up and work 1 through 20. Let's do 1 through 4. We'll do 1 through 4 together. So the limit as x approaches -3 from the left. So here's -3. As we approach -3 from the left, what's the answer? 0. As we approach -3 from the right, what do we get? 0. So what's the limit as x approaches -3? 0. What is f of -3? D and E. Oh. And you can also put undefined. And I made y'all be very specific about that, but Mr. Ackerman said really whether it does not exist or undefined, they're not real picky about that. They mean different things, like it's technically undefined, but we can use D and E, it's fine. Okay, we good? Any questions? All right, so I'm going to give you some time. I want you to work with your shoulder partner. Okay. So, I don't know what y'all are arguing about, but it may be, look at my paper. So the limit as x approaches -2 from the left. Okay? There's an asymptote there. So what do you think the answer is? Okay. So if you remember, which you may not because we wrote this, but it's kind of all in the same day. We think of it as negative infinity. Technically, it does not exist, but you say it does not exist, it decreases without bound kind of thing. So there are times where we think about it as negative infinity, and there are times where we say it does not exist, and then we can clarify that it decreases without bound. So this is kind of negative infinity and does not exist. Technically, it doesn't exist, but for purposes of understanding what's happening with the graph, we talk about, because negative infinity is not a number, right? Does that make sense? So if you want to say that a limit is infinity or negative infinity, we really are going to get to the point where we say it does not exist, decreases without bound, or increases without bound. If we're thinking about it as infinity right now, that's fine. I just want to clarify that so you don't think I'm like changing something on you. Okay? Okay, I think you can get through the rest of those then. I filled in my answers for 5 through 12. So just double check those. Tell me if you have any questions on 5 through 12. Okay, and then I'm going to write my other ones up there. You stop me if we need to talk about something. So 13, I got 1/2. We agree with that? No decimals, right? Unless we're given decimals. 14, I got -2. Yes? No? No. Okay, well, hang on. Maybe I'm wrong. Let's make sure. 14, okay, as x approaches 2 from the right, as I'm approaching 2 from the right, I get -2. What did you have? 3/2? Oh, okay. It's probably more because that kind of doesn't make sense. Thinking the graph is hard to read, and that's probably what messed you up. Okay, I don't think so. You didn't understand. Okay, good. -2. So then 15, I got these don't match, right? Even if I'm not looking at the graph right now, so that tells me this does not exist. So for 16, what is f of 2? 3/2. All right, we all good on those? 17, I got -1. 18, I got -1. So without even looking at the graph, what does 19 have to be? -1. What is f of 3? -3/2. Very good. Okay, we all good on all that? All right, so now I'm going to give you a minute. I want you individually to, it says, given the graph of f of x below, write 3 limit statements that describe the graph. So you're going to make up your own limit statement. Yours are going to be different than each other's. That's totally fine. Let's see what you got. While you do that, I'm going to hand out something else. Oh, be quiet. Write your limit. Oh, did you already do it? Look at you, little overachievers. No, that's fine. That's totally fine. That's fine. It's okay if you do it together. Because I want it, so what y'all are going to do then, since you did them together, I was going to have your neighbor kind of check them, so you'll just have to like trade with them or something. Oh, I'm sorry, I can't count. It's okay, we don't have to count a lot in here, we'll be fine. Don't do, well, I guess you could do these, but. And so go ahead and put the answer. So you're not going to put the limit as x approaches of f of x at x approaches whatever is whatever. And then when you're done, trade with your neighbor, and they're going to see if they agree with your statements. And there is You know, in calculus we talk about, we try and work kind of in the gray space, meaning there's not one right answer to this, and we're going to see if you can kind of go the other way. So check each other's. Make sure you think that their statements are right. Yes, ma'am. Do not agree with each other. Oh, okay. So this is fine. Like, these are true statements. It's not really, and it is describing the graph. So I would say it's not wrong. Because those are limit statements. They do describe the graph. This is what I was going for, but I don't think the instructions were clear enough to make you only do this. So I would say that is not wrong. Okay. So as long as the statement, so you can just check, make sure those statements are right. You can check and make sure these statements are right, and then, yeah, no, that's good, that's good. See, no, don't apologize. It's thinking outside the box, and like, maybe that would have been a better thing to have you do. You know? Yeah, I know. That's totally fine, totally fine. But that's okay. Like I said, it's not wrong. Basically, you follow the instructions, and so do we agree? Do I need to double check any? You're smart? Okay. All right, I'll leave you alone then. And once you've checked it, checked each other's, go ahead and grab that multiple choice. Let me know if I need to double check anything. No, that's just 2 more problems we're going to work, and then I'm going to give you the worksheet. Did you? Okay, well, that's good. I'm glad that they were there. So hopefully they were helpful. It's one reason why I don't take them down. I have people say, I went back and looked at them. Good. That's why they're there. Okay, did we all check each other? Are we good? Yes? Are we still checking? Okay, grab that other paper I gave you. Oh, it's still on this one. So this is not the worksheet. So what you'll have in a lot of our notes and assignments is also a couple of questions like what it might look like on the AP exam. Okay, so you know the AP exam, there's these are actually pulled from exams, all right? So they have a graph for you, and it says the figure above show the graph. That's not very good English, so maybe it's not actually pulled from the graph of the function of f. And so one thing you have to pay attention to, right now there's only one thing, but they might be asking you about f and show you a graph of g eventually. So make sure you're paying attention to what's what. Which of the following statements are true? All right, so this says the limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right. Do we think that's true? No, because they approach 2 different things. So Roman numeral 1 doesn't work, which means I can also mark out C, right? So then the limit as x approaches 6 from the left and 6 from the right, that's equal. Do we agree with that? Yes, so we like 2, which means we can eliminate B. So now if we got a 50-50 shot, right? The limit as x approaches 6 is equal to f of 6. No, because f of 6 is -3, so our answer is A. Okay? Look, you just got an AP question right. Look for you. Yay! That's a 5 right there. Okay, so here's the graph of function f. Which of the following statements is false? You have to, they no longer, bold those kind of words anymore. So the limit as x approaches 2 exists. As x approaches 2, does the limit exist? Yes? Yes. Okay, so that means it's not my answer. The limit as x approaches 3 exists. Yes, so that's not my answer. The limit as x approaches 4, does it exist? No. Should I stop looking? Or should I also read D? I should also read D, because what if I like D also? Something's wrong, right? Okay, so the limit as x approaches 5, does that exist? Yes. No, but you're right, you can't circle. But if I think that both of these are right, maybe it was supposed to say true and I got one of these wrong. You know what I mean? Because that's something that, or I think they're both true and I'm wrong and I got to figure out which one really is true. So you should always read all of the answer choices. Okay. So here's what I want you to do. I want you to fold this like you folded the other one where you can see the little title. You're going to turn in your ISN to page 21, because this goes on 20. I'm going to borrow yours real quick. So when you get to 21, when you get to 21 and 22, 21 is going to go right here, and then the other one will be on 22. You're just going to put a piece of tape, couple pieces of tape across the top. It doesn't feel like be solid tape, and then you'll be good to go. And I will hand out your assignment. I'll have the key for this posted. I'll post it on Schoology, but I'll also have it available for you to look at.
Yeah, we get a worksheet.
Yay! We had a lot of Delta Math. We're going to use Delta Math some, but paper assignments are also, did I give y'all too many? Because I couldn't count, okay. And on here, there's brief descriptions on the back, and you've got to use your words. So when you're using your words, I want you to look back at your notes and think about what the definitions of the limits are and things like that, okay? And at first, some of your explanations might be a little rough, but we're going to work on getting them there correctly, okay? Then you're going to do 3 limits on that one, and then I'm going to check to see if they're right. You got to